Business intelligence now is the flip side of the coin, where the first side is business performance management. So let's talk about that. So first of all, I will give you not an intro, but an intro. Then we're talking about data warehouses, data integration, analytics, and about data cubes as one methodology in order to analyze data. So what's business intelligence? Actually, business intelligence is an umbrella term, namely for applications, infrastructure, and tools, in order to support online analytical processing. It's also a set of best practices, how to do that. And it talks about how to access and analyze information and how to improve and optimize decisions and performance. All of that is captured by business intelligence, by the term business intelligence. And so there are different views that you might encounter when talking about business intelligence. So let's start with the most narrow view, namely the reporting view. And the most narrow kind of thing there is standard reporting. So you might have a reporting system in place, so that's part of your information infrastructure, and this reporting infrastructure defines who gets which reports at what time and so on, and that is something, a very narrow view of business intelligence, just talking about that. But sometimes the reporting view also covers some kind of what is called ad hoc reporting. In contrast to standard reporting, ad hoc reportings give the user some way to analyze things in their own way, not in a prefabricated way as the standard reports, but to have an individual view at the data, more individual view at the data in a certain restricted way, of course. The next broader view is talking about online analytical processing, or the analytics view. OLEP stands for online analytical processing. And there we have, of course, standard reporting is included in that. But there we have comprehensive ad hoc reporting, so that the user can follow their own goals in analytics. We have what is called multidimensional data analytics. I will come to that in a moment, what that means. And it supports also explorative data analysis. So you can follow, for example, if-when scenarios. So if you do this and that, what scenario? So what will be the outcome? And a common thing within the analytics view is termed by given by the term dashboards, that you have cockpits or dashboards that provide a comprehensive view of your KPIs. And the most comprehensive view of BI also encloses data warehouses and data integration. So the upper part here, that's all directly related to how the user deals with the BI system. And the lower part is how the data is ingested, how the data is transformed, how the data is structured, how it is integrated in order to provide the analytics view. Yeah, so data warehouse and data integration are two main aspects. And actually, when building a BI infrastructure, usually most of the work is done in this area here. This is the hard work to clean up your data, for example, to get your data, to ingest your data, and so on. So let's talk about a data warehouse. And there's one famous definition, it's already quite old, from one of the business BI popes. Actually, there are two popes in the BI arena, and from one of them, from one of them is this definition. So a data warehouse is a subject-oriented, integrated, time-variant, and non-volatile collection of data, usually used to improve decision making. Yeah. So let's dissect this definition a little bit in order to understand what is meant by that. So if you have a larger company in mind, for example, a company that might have been built up from different mergers during the time, yeah. And there, if you are merging, if the company has been developed over time, there have been mergers and so on, you can assume that the company has a lot of database systems, for example, for similar things. For example, you might have 2 or 3 databases where customer data is stored in. Yeah. Often the same data, for example, order data and so is spread over different systems. And this is the operational structuring of the data. And within a data warehouse, you try to organize your data based on subjects. That would mean that all data about customers is integrated. Yeah, all information about product is integrated in one single data warehouse. Yeah, so the structuring of the data is centered around subjects and not around technology or database systems. Integrated, I have already mentioned that. Let me just show you. For example, let's assume you have 2 databases for customers, and the information about gender is stored in the 2 databases. It's quite common that in one database it's stored using the letters F for female and M for male. And in a different database, it is stored 0 for males and 1 for females or so. So you might have different coding of the same data. And if you have this subject-oriented way, you have to provide an integrated way. That means you have to transform the data into one singular format. Yeah. The same might pertain, for example, to unit of measures. Yeah, if you're selling things and might be measured in pounds or in kilograms and so on. And integration transforms the data into one kind of unit, for example. Time variant. That means that historical data is maintained for a long period of time. Often, the operational systems are only storing the data of the current business period, or at least 1 or 2 years before. But if you need a longer time period, usually the data has to be collected in that way, and that's what usually is done in a data warehouse. And non-volatile means that data is not updated by users, but the change of data is handled by not by updating the data, but by having records that tell you what the change was. Yeah, so that you can, for example, if you have customer record, you might store different version, yeah, of the information of the customers, for example, in order to see where he lived, yeah. So if he moved somewhere, so you might have the history of his movements, yeah. And you just would not store the current address of him, yeah. You might also have previous addresses and so on, yeah. That is meant by volatile. Or for example, if you have errors in your records, yeah, you might have compensating records that are compensating for that, yeah. So in order to have the history and see what happened. There's also one term I haven't mentioned yet, that is this single point of truth, yeah. And there we have, the idea is that even if you have a quite large company, in the sense of the information architecture, you have one singular data warehouse where everything is consolidated. This most of the time is an ideal goal that is not reached, but this is the general idea behind it. More often, you might have many data warehouses within the company, yeah, so that you don't have one single point of truth, but it is, you have several of them, or you may have what are called data marts that are specific to certain divisions or departments and so on. Yeah, so this is more an ideal goal what you should strive at. Yeah, or strive for to reach that. So how is such kind of data warehouse architecture structured? So in the center here, you see we have the data warehouse itself, and actually you can regard it as one database. So for example, the adventure works that we have used in the rated exercise, that's a kind of data warehouse. Or the food mart that we have used during the lecture, that also could be some kind of data warehouse. Yeah. So this is the data warehouse is, yeah, the physical database where the consolidated data is stored and that is structured in a suitable way. On the other side, we have these we have the data sources. So this is meant, a premier example for that would be enterprise resource planning systems, so the operational systems the operation of the company is based on, or are based on, if there are more of them, yeah. But of course, it could be databases, it could be files, Excel sheet, for example, yeah. So quite often, given existing Excel sheets are imported into the data warehouse. Then we have APIs. That means that you can get data from several services, yeah, where you directly can connect with an application in order to get information out of it, yeah. Web services, yeah, for example, here stock market prices, or weather data, yeah. For example, if you try to analyze your revenue and you have a specific product category that might be influenced by weather conditions, then you might get weather information from web services in order to incorporate them into your analytics. And of course, social media channels, Facebook, Twitter, everything like that. And FTP, it's called file transfer protocol. That's usually used. That's quite common that you do not access the ERP systems directly, but the ERP system export some kind of file, and this file is put onto a server, and you get that file via the file transfer protocol from that server in order to ingest it in your data warehouse. So these are common data sources. And there's a whole bunch of a whole category of tools that are able to extract the data, to transform the data, for example, in order to provide consolidated views, the female male 0-1 transformation, for example, and load it into the data warehouse. And this is a category, it's called ETL tools. That you might have heard that term. That's a very famous, very well-known term in the BI world. Extract, transform, load. This is ETL. So if the data warehouse system has been established, of course you will use it in order to do analytics. That means you have a whole bunch of analytical tools in order to gain insight from the data. So one tool we are going to use here is Tableau, in order to visualize data. Another tool we are going to use is machine learning algorithms, but even the DB visualizer could also be regarded as some kind of tool, because you can apply SQL statements directly on the data warehouse, and actually this is the most powerful way. If you have to do some very complicated analytics, that's the way how you can do it. With Tableau and so on, you do visualizations. Of course, that's an important thing, to do. But sometimes, if you need more detailed analytics, you would refer to SQL. Okay, so that's the data warehouse architecture. So let's talk a little bit about extract, transform, and load. So extract means getting the data from the source system. Transform means, for example, clean up data. Do you have any idea what that could mean? Cleaning up data?
Organizing it.
Organizing it. I would say that would more fit to transform data.
Then maybe getting rid of the redundant things and stuff like that.
For example, remove duplicates. That would be cleaning data. That's correct. Other ideas? How to clean data? Or
maybe it's more like deleting unnecessary characters, for example, spaces. That could be
used. Although that might also be might be called transform, but you can call it also as cleaning. That would be an example. There's one important
line that
sorry.
Some old product line that are like completely absolute right now, and the company doesn't require that afterwards. Maybe if to remove the data regarding that, which is not useful.
Removing old data.
Which might not be useful afterwards.
Okay. Irrelevant data, for example, removing irrelevant data. So one famous thing, or one thing that immediately comes to mind, at least for BI persons, is missing data, if you have missing columns. If you have columns with no data, you have to clean that in some way. Yeah, either you have to remove the column or you have to impute it, as it called, values for that column. Normalize data. What is example of that? What do you think?
Normalize data in the way the system understands or we understand the data.
Yeah, so of course that's quite abstract. That's correct, but I would like to have a more concrete example. So one example I have already given. So if in your data warehouse you would like to code females with letter F, the gender female with letter F, and the gender male with letter M, and the source system provides it in a different way, you would normalize it to that standard value. Yeah, that's one thing. Another thing is this has more to do with statistical kind of things that you can. If your columns have data in different range, for example, if you have unit of measures, yeah, and you have it in kilogram and pounds, and you might store it in kilograms, yeah, that's also normalization. But there's also, that's called z-score normalization, where you transform the data such that it has standard deviation of 0 and mean of 0 and standard deviation of 1. That's a typical thing that you, for example, do in order to do machine learning kind of things. And transforming data, that's all other major operations that you do on data. Yeah, for example, split textual values where you have list of values separated by commas, or so, split them according into the comma and so on, and extract the corresponding parts out of it. Yeah. Okay, load, of course, then is storing data in the data warehouse. And the operations, the operations that you usually have there is, for example, for input-output, it's file access, database access, or API web services access. The manipulation could be, for example, filtering, that was removing old or irrelevant data, for example, splitting and union of data streams, yeah, that you have for given data. You might have different paths where you transform the data in a different way. So you split the data stream into different streams, and you transform each streams, and then you reunion that. Yeah, you join data. So if you combine data from different sources, that is something that is the same as you can regard it as a common database join. Yeah. Aggregation, also something that we have done in database and SQL, so that you put it on a different aggregation level. Yeah, so you get, for example, data on an event level. Yeah, let's assume you have clickstream data from a website. Yeah, and you aggregate it to on session data, so on a whole user session or something like that. Yeah, but also, of course, the usual aggregation that you have data and you aggregate it on the daily level, on the monthly level, or whatever. And of course, you can do all kinds of calculations with the data. Yeah, mean, standard deviations, medians, but also usual just multiplications, divisions, and whatever. Yeah, calculating percentages. All this kind of stuff. Yeah, so that there's a lot that can be done in order to shape the data in a useful way. Yeah, so before it gets into the data warehouse.